Hi, I'm Carol, here to share the wonderful population education lesson, Counting Carbon. This activity is written for upper elementary grades, covering skills and knowledge for both science and math. The focus of the lesson is carbon sinks. It starts by giving some context around the amount of CO2 emitted from some of our daily tasks, and then explores what carbon sinks are and why they're vital to a healthy planet. By participating in Counting Carbon, your students will be able to describe the connection between CO2 emissions and driving cars, define carbon sink using grade-level appropriate language, and identify 4 types of natural areas that can absorb and store CO2 from the atmosphere. You'll need biodegradable packing peanuts, the provided student worksheet, 3 gallon-size resealable bags, and 4 clear plastic containers with lids. Like I mentioned, we start with some context on CO2 emissions. Students complete word problems about how much CO2 is released from driving cars, and more specifically, the driving done to get an imaginary class of students to school. You are going to use packing peanuts to represent the carbon dioxide released from driving. In the word problems, students will assume that driving 1 mile releases 4 packing peanuts worth of CO2. As you go through the worksheet answers with the class, hold up prepared bags showing the number of packing peanuts, or CO2, corresponding with each answer. We'll ultimately see that in total, 160 packing peanuts of CO2 was released to get the entire class to school. So what does all of this have to do with carbon sinks? Let's move on to part 2 and find out. Carbon sinks are areas that absorb and store more CO2 than they emit. We are going to demonstrate how CO2 gets stored in 4 natural areas on Earth that serve as carbon sinks: oceans, forests, wetlands, and grasslands. Because of human activities, more CO2 is being emitted into the atmosphere than can be absorbed by carbon sinks. Scientists aren't exactly sure how much does not get absorbed. It could be as much as half of the Earth's CO2. But today, we'll conservatively assume that 10% of CO2 does not get absorbed into carbon sinks. So looking at the CO2 emitted by the imaginary class getting to school, remember that's 160 peanuts, 10% cannot be absorbed and stays in the atmosphere. 10% of 160 is 16. So we'll remove 16 peanuts, which I've already done. And the remaining 144 packing peanuts represent the CO2 that can be absorbed by carbon sinks. These packing peanuts that we're using today dissolve in water, just like CO2 gets absorbed over time into oceans, forests, wetlands, and grasslands. So these 4 containers that I've prepared each represent one of the 4 different types of natural carbon sinks, and we'll look at each carbon sink in turn, starting with the oceans. In class, you can read or invite a student to read the provided blurb about oceans. It says, about half of the CO2 absorbed by Earth is stored in the oceans. The oceans can do this when they're healthy because seaweed and types of plankton, small organisms found in the water, absorb CO2 during photosynthesis. Some of the seaweed and plankton sink to the bottom of the ocean, taking the CO2 with it. Now ask students to come up with an action to illustrate how the carbon sink absorbs and stores CO2. With oceans, I've asked one of my colleagues to give you an example. Here she is, pretending to be seaweed, grabbing CO2 and then sinking to the ground. Now while students do their carbon sink actions, I'll place the appropriate number of packing peanuts in the container. In this case, for oceans, that's half of the packing peanuts. I'll tightly close the lid and shake, making the peanuts dissolve. You'll go through the same process of the information blurb, student actions, and packing peanut demo for forests, wetlands, and grasslands. But we still have these 16 remaining peanuts. Since these packing peanuts, or CO2, didn't get absorbed by one of the carbon sinks, where do they go? Students will hopefully respond with the understanding that they will stay in the atmosphere. The first couple discussion questions are meant to reinforce direct information from the carbon sink activity. There are also questions about the impact of losing natural carbon sinks and how we might protect them. Additionally, we tie things back to those original word problems. Remember, in our model, we created 160 packing peanuts of CO2 by traveling to school. A lot of the peanuts were able to go into carbon sinks, but some of the peanuts couldn't fit and stayed in the atmosphere. This trapped CO2 is what leads to climate change. What could be changed so we don't have CO2 left in the atmosphere? It's a challenging question, but here's a hint. Encourage students to think of both where the CO2 comes from and where it goes. Is there something that we can do so that more CO2 is absorbed? Or is there something that we can do to change the amount of CO2 being produced? So that's counting carbon. I hope you'll give it a try, and definitely check out populationeducation.org for other great elementary lessons on human-environment interactions. Thank you.